Collisions are an important thing to understand because they play a role in everyday life. For example, everyday sports like tennis, baseball, bowling, and billiards wouldn't exist without having a careful understanding of how collisions work. It's important to remember Newton's three laws of motion, which are as follows. The first law, called the law of inertia, states that an object in a state of uniform motion tends to remain in that state unless acted upon by an external force, such as friction or air resistance. When the sum of the forces acting on an object equals zero, that object is in equilibrium. The second law simply states the relation between the mass and acceleration of an object and the force acting on it, giving force equals mass times acceleration, where force and acceleration are both vectors pointing in the same direction. The third law has to do with action-reaction forces. It states that for every action there is an equal and opposite reaction. This law is important to collisions because it means that objects that collide both exert forces on one another.
Two types of energy. 1. Kinetic energy, or Ke. 2. Potential energy, or Pe. Conservation of energy. Ke, or kinetic energy, equals 1/2 mv squared, where m equals mass and v equals velocity. Potential energy, or Pe, equals mgh, m being mass, g being the force of gravity, and h being the height of the object. Initial energy equals final energy, or kinetic energy plus potential energy of the object equals the final kinetic energy plus the final potential energy.
There are two types of collisions. The first one is elastic collision, and the second one is inelastic collision.
In any collision, momentum is always conserved. Momentum equals mass times velocity.
Next, let's discuss energy. In collisions, if the total external force on the system is zero, momentum is conserved. In an elastic collision, it is necessary to know that kinetic energy is conserved. In inelastic collisions, kinetic energy is not conserved. In an elastic collision, the colliding objects stay separate. In inelastic collisions, the colliding objects stick together. In both types of collisions, we will assume external forces are negligible so that momentum is conserved. The equation for elastic collisions is total initial momentum equals total final momentum, which translates to m1v1 initial plus m2v2 initial equals m1v1 final plus m2v2 final. The equation for inelastic collisions similarly is m1v1 initial plus m2v2 initial equals m1 plus m2 times their final velocity.
First, let's practice solving an elastic collision problem. Box 1 of mass 1 kilogram travels across a frictionless surface at 3 meters per second. Box 1 collides with box 2 of unknown mass that is at rest. After the collision, box 1 is traveling in the opposite direction at 2 meters per second. We want to solve for the mass of box 2 and its final velocity. Since we have two unknowns, we need to write two equations to solve for them. We will use the conservation of momentum and conservation of kinetic energy equations. Solving for m2, you get n1 times, in parentheses, v1 initial minus v1 final divided by v1 initial plus v1 final. Solving for v2 final, you get v1 initial plus v1 final. After plugging in the numbers, you get m2 of 5 kilograms and v2 final of 1 meter per second.
Again, on a frictionless surface, Box 1 with mass of 1 kilogram is traveling at 5 meters per second, while Box 2 with mass 2 kilograms is at rest. When the two boxes collide, they stick together and continue at an unknown velocity. Use the equation m1v1 plus m2v2 equals m1 plus m2 times v final. When you plug in the numbers, you get 5/3 meters per second as a final velocity.
Vivre, je vais me sauver. Faut que je fasse pas, pas,